let's look at a problem involving integrating rational functions. Notice that in this problem, we cannot use substitution, so we have to think of another way. In this case, the degree of the numerator is greater than the degree of the denominator, so we can rewrite the integrand using long division. So, dividing 3x squared plus 5x plus 1 by x plus 2 gives 3x minus 1 plus 3 over x plus 2. We can now divide this into three simple integrals. That gives us the integral of 3x dx minus 1 dx plus 3 over x plus 2 dx. Integrating, we get 3x squared over 2 minus x, and then using a simple substitution, we get plus 3 times the natural log of x plus 2 plus c. Now let's look at a little more complex problem involving integrating rational functions. Since the degree of the numerator is greater than the degree of the denominator, we can make the integrand a little easier to deal with by dividing. First, let's rewrite the numerator so one term contains the expression in the denominator. We can factor the numerators as x times x squared minus 3x plus 2 plus 2x minus 1. Now let's divide. We get the integral of x plus 2x minus 1 over x squared minus 3x plus 2 dx. Now we have a first term that can be easily integrated, but the second term is not so simple. We cannot use substitution, and since the degree of the numerator is less than the degree of the denominator, we cannot simplify using division. However, when we have a rational expression in which the degree of the numerator is less than the degree of the denominator, we can rewrite the expression using partial fraction decomposition. First, we'll factor the denominator, and then we'll set the expression to the sum of a over one factor and b over the other factor. Next, we clear the equation of fractions by multiplying both sides of the equation by the common denominator. Now we multiply on the right side and group the coefficients of x and the constants. In order for these two expressions to be equal, we must have a plus b equal to 2, and negative 2a minus b equal to negative 1. Solving this first equation for b, we get b equals 2 minus a. Substituting into the second equation, we get negative 2a minus 2 minus a. Simplifying and isolating the a term on the left, we get negative a is equal to 1. So we get a is equal to negative 1. Substituting this into the equation b equals 2 minus a, we get that b is equal to 3. We can now rewrite the second term in the integrand. We get the integral of x minus 1 over x minus 1 plus 3 over x minus 2 dx. We now have a fairly simple integral to integrate. Thus, we get x squared over 2 minus the natural log of x minus 1 plus 3 times the natural log of x minus 2 plus c. So, we saw here that we can often take what look like complex integrals and turn them into much simpler integrals using long division and partial fraction decomposition.